Hey guys, just a heads up before we talk about this, everything about containers, that's Docker in this video, second part of a three-part video series. I just wanted to tell that a lot of you guys were struggling to find where to find out all the three parts. So that's available on k21academy.com/Kubernetes, where you'll get all the three parts. First part about container or like overview of containers and Kubernetes. This part will talk about Docker that you probably might be seeing everything about Docker, and third part, which is everything about Kubernetes, which will be putting under on the page k21academy.com/Kubernetes. That's a page you'll have all three of them. With that, let's see what we're going to cover in this part two of three-part video series on containers and Kubernetes. So let's continue from the part one where we earlier, and in this section we're going to talk about the Docker or containers. We'll look at everything that you need to know from a high level bird's eye view about Docker and how you can go deeper. We'll talk about that, but quickly I'll do quick recap on what we've covered so that you know and you're familiar. We started with the evolution of development and deployment in the previous section. Then we looked at the deployment or how the deployment happened, moved from bare metal to virtual machine to containers to Kubernetes, the different type of hypervisors, which is type 1 and type 2, the difference between virtual machine and containers, and why containers, which is Docker is example of containers, why it's becoming famous. Then monolithic versus microservices, containers, how do you run these microservices on top of containers, different container runtime options, and container orchestration tool like Kubernetes and OpenShift. So let's begin with, and then we finally also looked at it briefly, the deployment of this Kubernetes on cloud we call managed Kubernetes for all the four top cloud vendors. So with that, I also mentioned about this CI/CD pipeline using which we are going to deploy the Kubernetes, which we'll talk about a little bit later on how to deploy that applications on that. So now let's look at the Docker or container. When I'm going to use word Docker, we're going to use interchangeably. And the first and most important thing for that is to understand this architecture that you see here. So typically that is where the central place you have a Docker host. This is the machine on which you're going to run. You've installed, assuming a container runtime like Docker. On using that Docker, in the behind the scene, there is a Docker daemon, which is a process which is always running behind the scene, which will be the primary component that will be starting managing your containers. So this is where you see, if you look at this machine, there are 1, 2, 3, 4 containers are running. Now these containers are created using image. What this image is, we'll talk about that in a minute, what these different images are. Now these images are stored in a registry. Later we'll see what a registry is. Basically, it's nothing but an image repository from which you can download these images, and through images you create these containers. So you have an image registry, you have a container, a Docker host, and then client through which you manage these Docker commands where you start containers, create image, etc. So there are some commands like Docker build, pull, run. Different commands will see that. This is a 30,000 foot view, easy, simple component or Docker architecture. That's how it looks like. Now, if you see in a different view of Docker engine, behind, if you see the innermost, you have a server, which is Docker daemon. Daemon is nothing but a process that always runs behind the scene that has a REST API interface, which will be basically interacting any commands that come, they interface through REST API interface and then being fired onto this backend server, which is, you see Docker daemon here. Now, you also have client which can be installed within the same host or another host through which we call Docker command line interface that basically uses to manage your containers where you start and stop containers and do other activities. And then you also manage images using this command Docker command line. Now, this whole Docker, basically you, in order to store the persistent data, which means even after restart of that container, the data stays. That is something called as data volume or storage or persistent volume, which we'll see later. It manages, the Docker manages the persistent volume. Now, Docker or Docker components or the application will need some networking, and that is where the network, it basically manages the network and different type of network that you're going to see. So that's basically main components of Docker. Now, in terms of terminologies, so there's something called Docker image, which we'll see in a minute, that's being created using a Docker file. Now, Docker file contains all your application and its dependencies. So let's suppose you're running a Python application. So Python will need some Python libraries. You're running a SQL database, so it'll need a SQL library, binaries, etc. Those and this application on top of that is being run, which we call basically. And then container, a Docker container is an instance of an image. Image will, through image, you're going to start, and what images we'll see that in a minute. So here, this is one container. This is representing second container. It will be built using images, which we'll see in a minute. So that's in a simple terminology that we'll see. So how it works, you have something called as Docker file, which is nothing but a set of instructions developed or written by your developer that will have all the code, and through which Docker, using Docker file, you create something called as Docker image. So you'll say build Docker image, it'll go and build the image. Now this basically, using this image, you start the containers, and these both images and containers are running inside, or images are stored inside a virtual machine or a operating system. Same as containers, they run on top of an operating system. Now, these images are stored in a Docker image repository, Docker Hub. We'll see that a little bit later as well. And from this Docker Hub, you can, let's suppose you have multiple environments, you have a staging environment, you have a production environment, and you're saying through an image which is stored in Docker Hub, you can pull that image and say, hey, start a container. And that's how you see two instances of one in production, one in staging side containers running. Now, in terms of installation, there are different type of install you can do. There is a community edition, which is free. There's an enterprise edition, which is paid, which has some more features compared to community edition. Now, where can you install these container Docker? You can install in on-premise within your data center. You can even install it in your laptop. We'll see that in a minute, on your Windows laptop, Mac, or Linux, etc. You can also put them into cloud, on any cloud, AWS, Azure, Google, IBM, whatever cloud you can think of. It can also, as I said just now, on your own laptop, desktop, or servers, or virtual machines, or data center. Now, these Docker can be installed on supported operating system like Linux, Windows, Mac, etc. Now, inside the program, inside the module called Docker installation container images, you will have a step-by-step instructions to how to install this Docker on Windows, Mac, and Linux. And before that, even you install, we are going to do it on Ubuntu and a particular flavor of Ubuntu. So as long as you have a cloud account, if you don't, I would prefer you to do it on a cloud, because then we can have the standard operating system and standard all the dependencies by binaries. So what you're going to do is inside the portal, you will have if you don't have any account, you can create either an Azure or AWS or Google, whatever of your choice, and then create a Ubuntu type machine. You will have this lesson where you go to step-by-step instructions and video. This is a video of around 19 minutes where you go and install an Ubuntu machine on Azure cloud. If you want to do it on AWS, there should be a create and manage an Ubuntu on AWS as well. And if you're doing it on other cloud, just let us know. We can create a video inside and put it inside the portal. Then we are going to do is inside that Ubuntu, then how do you install that Docker and how do you start applications? All those are inside the guide that you will see, the portal. Now, what you see here is 18.04. By the time you're watching that, it might be 20 or newer version. So the guide keeps updating. So make sure that you're using the right version of Ubuntu on which we have given the instructions for you. So task for you, go and complete this lab. That will be helpful. These are the step-by-step instructions on that. We'll see. I picked up a screenshot from the portal. You will be doing and installing this Docker. And finally, you should have a Docker version ready. It will tell you the version. Now, one common mistake which people do is that they don't follow the instruction. And here in this, later you will see when you go to this video, you will understand that you are adding the user through which you're installing. So if you're installing, for example, you might have a operating system user called Ubuntu or Red Hat or whatever name of your choice. You need to add that user permissions right group so that this can be managed. Now, again, you may not be understanding. It might be complicated. Don't worry about it. Just listen to this video inside the portal and go and perform this lab on Ubuntu. Once you've gone through this video, after this, go and install this action for you here. Now, once you've installed the Docker, then within the same guide, you will have another guide on how to work with containers. So you'll be starting some containers through a predefined images. So when you start the container, this is the container lifecycle. You can create a container which will go into the state of created. Once it's created, you can go for start it, or you can directly say start and it will go and create if it's not there, and as well as start it. It's basically then it'll come into a stage called running. Running a container, you can do multiple operations. You can pause, you can unpause, you can start, you can stop, and then a stop environment you can delete, or you can directly say delete, it will stop and delete it as well, and so on. Or directly create a container you can delete. So there are multiple operations. Now inside the program, inside the training program, we'll go deeper into these different commands that you see, and this is the full picture on in terms of when you say Docker run, it will go and create, and so it will say Docker run, it will create an instance. Behind the scene, when you say Docker create, it will create, and then you can destroy, delete, or you can give a command and say start the container and so on. Like that, in running container, you can do all these operations. Again, we'll go and teach or talk about that deeper. I want to keep it high level this right now here. This is us talking about how these containers are created is you have a Docker file which will set the instructions. Again, how to do it, there'll be a step-by-step video, and creating your first container from scratch if you're a developer, that will be handy. So use the Docker file, and then using this Docker file, you create an image. And from this image, you're going to start the container. So that is the whole flow is going to be. So you can have image will can have multiple layers, which we'll see later. But don't worry right now. Just think of it as in something using which as a template through which you're starting the multiple containers. So image is nothing but a binary version of the entire dependencies. Like let's suppose you have a library, binaries, executable, code, everything inside that. And all you need to do is just say that using this image, start my container, and it'll start the container. Okay, so that's basically a high level container and image and containers. Now image, as when we build the images, you will see it has different layers. So let's suppose you are building a .NET based application. So we'll say that I'm basing it on a .NET layer operating system. So .NET base layer, and then on top of that, if it's a Python code, you'll write a Python. You will install the required Python, but you're only going to install as a good practice only things that you need. In this example, I'm creating a image of which runs on top of Ubuntu. So I'm going to take a very light version of Ubuntu. You're not going to take a full version of Ubuntu because that will become otherwise very heavy. So you'll take a very light version of Ubuntu, only things that you need. And then if you need anything further, which is not in that base image, you can add more and more. So in this case, for example, I've added Python, I've added my source code and built that an image. So that is how you create and build image. You Docker image and then help Docker and then help. It will tell you what all the options you can do. Image is one of them. So then within Docker image, then again type help, and it will tell you what all things you can do from images. You can build it, you can check the history, you can inspect, you can load, you can list, you can prune, pull, push, delete. A lot of operations you can do in image. So again, I'll keep bringing you back onto these hands-on lab because theory is good here, but actually go inside the portal and attend and perform these labs. That's when will become much more things will become much more clear. So there is a more in-depth 32-minute video. Will go inside the portal, and then you say that, and then there will be a lab on working with containers and creating the images as well. So there is a next chapter number 6 name here, working with the Docker images, and that will tell you about that images. Now, once these images are there, these images are stored in a repo, and that repo is called as a registry. So multiple repos bundled into a registry. That is nothing but the place where you store all the images. Think of it as a parking garage, and where you all your different cars are. There may be different levels of parking. So that is nothing but registry. And there are multiple registries. Docker Hub is one of the biggest one. So Docker Hub is from a Docker organization, as name suggests, in which you can contain or create registries. But the same Docker registry implementation on AWS cloud is AWS ECR, Elastic Container Registry. You have an Oracle Container Registry for Oracle's implementation of this registry on cloud. Microsoft Azure's implementation on cloud registry on which is called as Azure Container Registry, and same thing from Google Container Registry on Google Cloud. When you go and search for Google Container Registry, you should be able to see create a registry which is nothing but multiple repos, and then inside that repo you can create multiple versions and copies of these images as well. So that's a container registry which you should be knowing. Later we are going to do some labs on that. Here's an example of Docker Hub. In that, if you just type hub.docker, I think it's hub.docker.com or something like that, just Google on Docker Hub, you will see these are different categories of the images which are there. There are images from a verified publisher. There are images which are officially done by Docker. There'll be unverified images. And also there are categories like database images or a virtual machine, monitoring, DevOps, different type of images you can do. And also you'll have a filter based on the operating system version as well. And that will tell you how many downloads are there, etc., as well. So these are Docker images or the registry Docker Hub registry. Now, in registry, what you can do a lot of operations. So let's suppose you have a Docker registry, Docker Hub. You can push an image from your laptop or from a developer machine onto the Docker Hub, which I'm basically sending or storing my image onto Docker Hub or a registry, or I'm pulling the Docker image from onto my local machine, which is based here. I can create a tag, which what is tag, we'll see that later. You can do a backup and restore of this whole local image repository. Through image, you can create a containers and you can start, stop, and restart these containers or commit a container. Let's suppose you have updated something when you're working on the container and you save and you say commit, it can create a new image of that container. And these container images are created using Docker file. So I hope you understand the full picture now on these Docker images and registries. So what you do is after this class, as I said, after once you've gone through this basic high-level overview, go inside the program and create Docker images. So it'll be a Docker layers. What are the different layers? Once you do that, things will become much more clear. The guide covers Docker. How do you create those images, layers, commands, and then Docker private registry. Create the Docker private registry is there. Now there's a video inside the portal. This is how my Docker file look like. So I'm saying I'm taking this whole implementation on CentOS OS version 7, lighter version of CentOS. This is what I'm saying. I'm then saying label this with some who's the creator here. I want to do some operations on this, which I'm putting in this Docker file. And then it's basically nothing but copying the index.html onto something, and I'm installing some Nginx server here. So your developer will do these tasks. And once this is done, I say the Docker container run name, and then it will create, it will, sorry, there'll be another command to build that image. And now from that image, I'm running the container. The build name I've created is a web01 as well. Now, the best thing would be, how do you create? There'll be a dedicated module again inside the portal. You go and create automated image creation using Docker file, and then whole chapter about it'll explain you how to build that as well. So if you're a developer or would like to do a little bit development, or it's worth going through and see an experience on, because when you're working as an architect, these things will come handy for you. Yeah. So that's in a Docker, basically images. Now let's move on. As I said, I'm going to keep it high level because in depth, if you want to go inside the program and then portal and look at and go in a little bit deeper into these topics here. So the next is we are saying the networking, which is very important. Now there are different type of networking. Networking help you to connect and talk with different applications within a container or across containers. So let's suppose this is a machine in which you have a container, application 1, container application 2, application 3, and in that we have installed and configured a bridge type of network, and so that they all have different IP addresses. Each container will have its own IP addresses, and they talk to the external network through this machine on which these containers run through and port. So there's a bridge network. Now, there are other two type of networking. There's a host network and a MacVLAN network. We're not going to go, you don't need to become an expert in container networking. Understand and create a different type of network using these lessons, bridge, host, and MacVLAN, and do some hands-on lab creating a default bridge networking and a custom bridge networking that will help you to understand how the networking works in containers. But later in Kubernetes part, we're going to go deeper and look and go deeper into these Kubernetes concepts, and networking becomes much important there. So we'll focus a lot more on networking in the Kubernetes section rather than Docker, but at least do these labs for you. So that's basically in 30,000 foot view, bird's eye view networking. Next is storage. Now there are two type of storage. One is temporary storage and second is permanent storage or persistent volume we call. Now container will need both of them or may need both of them. So container during the life cycle, when it's up and running, it might need some temporary storage. That's we call tempfs or mount. Tempfs mount, which is anything that it needs to store something temporarily, it'll store in this place. But you can also attach a permanent storage. So you can attach it to the container so that if container is dead, if you want to start a new container, you can attach with this with this storage again, and you will have the container, we can see the data, because container can die, container can be killed. So what you need to do is, if you have a persistent data like your logs or application data, it has written something, or maybe a database, you put all of that into an external storage so that your container can then use, or new container can use this storage as well. So that's called as storage or persistent volumes. Now, you can also have configured in a manner which means multiple containers are sharing the same volume or storage. I use word interchangeably, so that's also possible. So again, make sure you go and perform and go through these more in depth about what is the Docker storage and bind, how do you bind volumes, what are the storage volumes, temp fs, and then what is the mounting of that storage, how do you mount them, how do you use them. Make sure you perform these hands-on lab theory part as well as the practical part, and then do Docker storage, host path mounting, and Docker volume, these two labs within the Docker container training inside the portal. That will become much more clear. Again, I want to keep it high level, short, to the point, so that you understand. And I want to make sure that, and as an architect, as a high level person, or as a beginner, you understand these concepts well. Now, it's when the container started, initially it was for not for a databases, but over a period of years now, the containerized databases are becoming mainstream, and there are a lot of containerized databases. You have a Cockroach DB, you have a Couch DB, you have a MariaDB, SQL, Mongo, and a lot more. Even Oracle database, MySQL databases, containerized databases you can build. Again, how do you build? There's an image available, and just spin off and say, I want to start that container of that particular database. Or you can install your own image, create, and build your own image with a database on that. Now, inside the portal, again, you will have a lab on how to get the databases deploy both in containers as well as Kubernetes. So this is an example where it's showing the database, which is MySQL database running. Also, there'll be a lab on PostgreSQL database, but we are going to do this on Kubernetes cluster so that you can understand the databases both in containers as well as Kubernetes. So don't forget to make sure that you complete this Kubernetes cluster as well. Now, another thing is a Docker Compose, and later as we go, you will see in when we come to the contain Kubernetes, there'll be a multi-container application which will have multiple containers. Some applications might need to have multiple containers, and Docker Compose helps you to create, define, and share these multi-container applications. It will build everything for you. So let's suppose you have you want a application which is basically doing some processing, and two applications working very closely with each other. Probably application database, take an example. The Docker Compose will help you to create and share and manage multi-container applications. There are other tools as well, which we'll see later, but make sure, again, if you're working a little more developer, then you might worth looking at Docker Compose. But if you're an admin or an architect, think of it as understand that, and make sure that you do one lab on how to work with an application stack, build a Docker Compose multi-part application worth doing. How do you containerize the application using Docker Compose as well, Docker and Docker Compose. So make sure you complete the hands-on lab. Now, with that, as I said earlier, I'm not going to repeat it. There's a container orchestration tool, which are like Apache Mesos and Docker Compose, Docker Swarm. And this is where you have another container like Kubernetes container orchestration tool, that's Docker Swarm. And Docker Swarm is nothing but a container orchestration with Kubernetes that initially back in I think 13, 14, 15 it was picking up, but then when Google donated Kubernetes, it became Kubernetes was picked up very quickly by open source community, and that started becoming more and more famous. So in the program, if you want to do it, maybe do. If you're using implementing Docker Swarm, then do it. Otherwise, you can skip this part. But if you have time, if you want to do it, then you can do how to use that Docker Swarm as well. We have a guide and video on how to install that Docker Swarm and configure them. But make sure before that you have done these labs that I've highlighted to you, right from installing, and first task will be to install and configure the containers on a Ubuntu machine. Once that container is up and running, maybe play with start in some containers. Then make sure that you play and create and manage your Docker images, which will be handy. Do that particular lab as well. Also, then play with some images. Make sure you create the Docker file and create a Docker image using those Docker file networking and storage as well. Well, that was everything about Docker containers. So now in the part 3, which will be available on our website, k21academy.com/Kubernetes, there you will also find all the 3 parts. If you've missed part 1, part 2 that you were just looking at, part 3. So let me talk you and guide you on what you could expect in this. This is going to be roughly around 1 hour class. Everything about Kubernetes, like things like Kubernetes components, what makes Kubernetes master node, worker node. We'll look at Kubernetes architecture. What are the components that make like things like Kube API server, etcd, Kube scheduler, cloud control manager, and controller manager. Then on worker node, we have kubelet, kube proxy, and container runtime like Docker and other things as well. What each of these components do. We'll also look at the difference between pod or another component that you do know, pod, and difference between container and virtual machine with pod. How does pod, you create the pods, pod lifecycle, and deployment, which is very important if you're doing high availability, scalability, if you're to make sure that the pods, which is nothing but containers, one or more containers, management of that through deployments. Also, now we'll also look at node, and we'll touch base briefly about node affinity and anti-affinity, which is making sure that what these means, tent and tolerations on that, and then multi-container pod if you're a developer or an architect, very, very important, especially what the sidecar means. We'll also look at Kubernetes services. And most important is ingress controller. What actually a lot of guys get confused about ingress controller. So what does ingress controller means? We'll also look at a life cycle of or persistent volume. That's PV and persistent volume claims, stateful applications, and then highly available application and scalable applications that you're going to see that as well. How do you do the rolling deployments? Or these are the things that you should be knowing. Auto scaling with horizontal pod auto scaling, and the tasks that you want to perform, which is job and cron job as well. You'll also briefly touch base with 4 levels of security, scanning the images, role-based access control, network policies, namespace, config map, secrets, what are these are as well as are there. So make sure, go and check it out by going to k21academy.com/Kubernetes. You'll also have an opportunity to book a call with my team or 15-minute or to see if you need any help with your career, any guidance that you need, or if you're stuck in your career or you want to go deeper into these topics. So hit k21academy.com/Kubernetes, and I'll see you in third part of this series.